In this section, 1.5, we're going to review really quickly how to solve inequalities. So we're going to look at three different ways to write inequalities. First one is graphically. So how does inequality look on a graph? The second one is kind of what you're probably going to see the most, which is the inequality notation. And then the third one is a written description. So something like you will see this in like a sentence or some kind of word problem. So let's just look at these four examples. The first one, x greater than 3. X greater than 3. So how would that look like on a graph? Well, x greater than 3 means that something's going to happen at 3. So we're going to have 3 on the number line. And then greater than means we're going to look at all the numbers that's greater than 3 but not equal to 3. And so because it's greater than 3 but not equal to, we put an open circle, meaning it's not equal to 3. And then we want all the numbers that's greater than 3, so we draw an arrow pointing to the right. Or some of your teachers may have showed you in the past to shade this part bigger than 3. That is also correct. So both ways are fine. Now, let's look at the next one. X greater than or equal to 3. Or equal to 3. So this time, we're going to put a closed circle on 3 and then point towards the right. So pretty easy. Okay, the next one, x less than 3. Less than 3 means we're going to, again, put an open circle on 3 because we're not including 3. And then put an arrow less than 3. And then the last one, x less than or equal to 3. So again, it's at 3. This time it does include because there's a or equal to, and then we put an arrow less than 3. Now let's explore really quickly what are some of the ways that you will see in a word problem that actually means any of those inequality notations. So for example, first one, x greater than 3, then written description, you're probably going to see x is greater than 3. So pretty easy. Greater than 3. What is another way of that you're going to see that means greater than 3? So maybe larger than 3. So another way to say greater than. Another way you're going to see something that is greater than 3 is something like more than. X is more than 3. So whatever the x is, it is more than 3. More than 3 means it's not equal to 3, right? It's got to be more. Something more than 3, so 3.1 or something, but not equal to 3, but bigger. Another way you're going to see this is above. X is above 3, so not 3, but bigger than 3. So x is above 3 is another way to say that. Then what about x is greater than or equal to? So greater than or equal to. That's kind of the standard way of saying this. What's another way that means greater than or equal to? It's a little bit trickier. What about at least? X is at least 3. So like for example, someone says, oh, the price of that Coke is at least 3. So that means it's $3 or more. So at least means greater than or equal to. Another way to say this is not less than. Not less than. This than in this case is not the less than we talked about in the previous section because this one has a is. X is less, not less than. X is not less than. So basically, we are saying that this number cannot be less than 3. So that means it must be 3 or more. And then so kind of from that logic, you can say that another way to say this is not smaller than. Not smaller than. So another way of saying not less than. And another one that comes up a lot is minimum. x is a minimum of 3. So the smallest number x can be is 3. So that's another way of saying greater than or equal to. All right, so some of these words. Okay, now we're going to look at the less than and less than or equal to. So kind of in that same way, but in the previous two examples are all greater than. Now we're going to switch to the other direction. So kind of think of the opposite word of all these that we just talked about. So for example, the first one, greater than. We talked about greater than. So then what's the opposite phrase of greater than? So less than. X is less than 3. This is what we always say. Then what is the opposite of saying larger than? That would be smaller than. X is smaller than 3. What about more than? More than is kind of the same as less than, so we got that covered. And then the last one, above. So what is the opposite word of above? That would be below. So when you say x is below 3, you're not saying 3 or less. You're just saying smaller than 3. Okay, so not equal to 3. Okay, now let's look at these ones. So less than or equal to. So less than or equal to is the opposite phrase of greater than or equal to. So that is kind of the standard way of saying this. X is less than or equal to. Then what is the opposite way of saying at least? What's the opposite of at least? That would be at most. When you say something is at most 3, that means 3 has to be the highest number. So that means anything 3 or below is fine. So that's another way of saying x is less than or equal to 3. What about not less than? What's the opposite way of saying not less than? That would be not greater than. Ooh, my A is not looking good. Greater than. Not greater than 3. So something not greater than 3 is 3 or less. Okay, not greater than 3 or not less than and not smaller than are the same. So I'm going to leave it as both. The opposite phrase is not greater than. And the last one, what is the opposite of saying minimum? Maximum, right? So maximum 3 is another way of saying that is x is less than or equal to 3. All right, so let's go ahead and translate these. First thing I do want to talk about is who always starts the conversation. So for me, the way we write or the way I write is I always write x first. So x always starts the conversation. So I'm probably going to ask you this in class a lot. Who starts the conversation? You would say x. So when you write x is less than 3, you will write it this way. Some people will write it this way. I find it very, very confusing because now you got to kind of think backwards. So what numbers work? Wait, 4? No, 2? And it's very confusing. So I always just say x starts the conversation. So x starts first. Don't write numbers first. It's just too confusing. All right. Now let us do 2 examples first, and then you can go ahead and practice. First, write an inequality that represents the sentence. 5 fewer than a number is at least 12. So let's kind of try to, translate everything. Okay, so first 5 fewer than. Fewer than, we remember that from last section. That is a turnaround word. A number, some kind of variable, that's equal to. At least is greater than or equal to 12. Okay, but 5 fewer than a number, so that means there's a turnaround, so that means x minus 5 is greater than equal to 12. You don't have to solve anything. This is just asking you to write an inequality that represents the sentence. Okay, next. The quotient of a number. Quotient, remember, is the result of a division problem. A number, some random variable, and 3, so x over 3, is no more than. No more than means it is at most something. So no more than 15. And if you forget at any given time, just go back to this chart and then, I'm sorry, I circled the wrong one. No more than, I guess I forgot to write this, no more than. You can go back to that chart and then just use it to kind of do a matching game. All right, so go ahead and pause the video and try these two practice problems. Okay, did you get these questions right? All right, now let's go ahead and try to solve these. Okay, so let's look at this question. What is the solution of negative 3 times parentheses 2x minus 5 plus 1 greater than or equal to 4? Graph the solution. So how should we solve this? Well, there are a few things you can do. I would subtract 1 first. Negative 3 times 2x minus 5 greater than or equal to 3. And the next thing we want to do is probably divide it by negative 3. Now you might say, why don't you distribute? Of course you could, but distributing it, remember, gives it to everybody. So now everybody has a negative 3 times that. And so you basically made the numbers a lot bigger. And so a lot of times it's just easier if you don't distribute, when you could just get rid of it by dividing, and you get a really nice number. You can see that 3 divided by negative 3, it's going to give you a very nice number. Then I would just divide. So I'm going to do that instead. So divide by negative 3. And then I get, I'm going to write it on here on the right, 2x minus 5, negative 1. Now I didn't write the sign in between because I want you to remember what happens if I divide by a negative number, or if I multiply by a negative number in an inequality question. What happens to the sign? So if I ever divide or multiply by a negative number, I have to switch the sign. This is very important. A lot of people make this mistake. So you have to switch the sign when you multiply or divide by a negative number. Okay, now we can just solve it. So plus 5 plus 5, 2x less than equal to 4, divided by 2, x is less than equal to 2. So very easy. Close circle on 2, less than. All right, let's go ahead and have you try number 2. Pause the video and try this. All right, did you get the correct answer? So please be careful with dividing by the negative. Make sure you switch the sign, and also just keep track of your negatives throughout the problem. All right, let's look at some word problem. First question says, a movie rental company offers 2 subscription plans. You can pay $36 a month and rent as many movies as desired, or you can pay $15 a month and $1.50 to rent each movie. How many movies must you rent in a month for the first plan to cost less than the second plan? Okay, that's a lot of words. So what you want to do when you see a word problem is first, you go straight to the question part. The question part is really the key. It really is what you are trying to solve. So if you could create some kind of equation, inequality, or some kind of mathematical thing out of that sentence, you could go back into the actual information part and then fill that in. So it makes the problem a lot easier. So let's look at that question part and see if there's anything we can do to translate that. Okay, how many movies? How many movies is what we're trying to solve, so we can call that X. Movies X. Must you rent in a month for the what? What is this? What does this question want? It wants the first plan to cost less than the second plan. So they want us to find X so that first plan costs less than the second plan. So now we have a plan. We just need to figure out what the first plan is and what the second plan is. So let's go to the information part. What is the first subscription plan? The first subscription plan says you can pay $36 a month and rent as many movies as you want. So that is the first plan. Or the second plan. The second plan is to pay $15 a month, and then you pay $1.50 every time you rent a movie. So that is the second plan. So then let's just fill that in. The first plan is $36. The second plan is you pay $15 first, but every time you rent a movie, so you add another 1.5 every time you rent a movie, and movies is X. So then now this is a very easy problem you can solve. So it all really depends on you writing this out correctly, and then you would do that by just deciphering that sentence, change it into a mathematical equation or inequality. Okay, so you get to this point, 21 is less than 1.5x, divide by 1.5, you can use your calculator. So you get 14 less than x. Is this the correct way to write your answer according to Miss Young? No. Remember, x starts the conversation, so x greater than 14. Now, what is the answer? The question says, how many movies must you rent so that the first plan costs less than the second plan? We said the answer is x greater than 14, so then what is the answer? 15. Why? Because if you rent 14 movies, then both plans cost the same. But when you start renting the 15th movie, then the first plan is going to cost less than the second plan. All right, let's pause the video and have you try the second one. All right, let's look at your answer. So we want the second plan to cost less than the first plan. Set up the equation, so we got x is greater than 32, or once you start downloading 33 songs or more, you start to cost less. All right, let's really quickly, I'm only going to pick a few for you to try because these are not very hard questions. So let's have you try number 1, number 4, number 3, circling 3, but I said 4, number 5 and 7. So I guess all the odd ones. So pause the video and try these 4. So here I have shown you answers to 1, 3, and 5. So go ahead and check those really quickly. I think a lot of people usually get stuck on number 7, so let's really quickly help you out. So it's a different kind of word problem as the one I had just showed you. But it's kind of the same idea. You just need to translate this problem into some kind of mathematical equation. Okay, so a school principal estimates that no more than, all right, kind of keyword here, no more than 6% of this year's senior class will graduate with honors. If 350 students graduate this year, how many will graduate with honors? Okay, how many will graduate with honors is what we're looking for, so that's kind of the X. But the sentence that we need to translate is here, because that tells us how many people will graduate with honors, which is what we're solving for. And then the first sentence tells us these are the people graduating with honors. Sometimes you want to go back and look for key phrases that repeat. So kind of like that, graduate with honors. Oh, it came up again in the first sentence. Okay, so The principle says no more than, so the people who are graduating with honors is no more than 6%. Let's remind ourselves, what is 6% in decimal form? That is 0.06. Of, remember from the previous section, what does of mean? Multiply. This year's senior, they're all graduating. So how many seniors are graduating this year? 350. So then you solve that, x is less than or equal to 21. So at most, 21 people will graduate with honors. All right, in this section, the last part is this always, sometimes, but never, and with inequality this time. So same idea as before. Let's just solve it and I'll show you why that is. Okay, so first question, 3x less than 12. So what is x? Divide by 3, x is greater than 4. X is greater than 4, so when is it true? Only when x is greater than 4. Meaning, if I make x 5, it will work. If I make x 0, it will not work, right? If I put in 0 in here, I get 0 greater than 12. Is that true? No. So it only works when this happens. So basically when there is one solution, meaning if you can solve it, then it's sometimes true. So almost, I mean, it is pretty much identical to the previous section like that. Next one, always true. In this kind of problem, just like before, if you try to solve it, then you would subtract 2x on both sides. You get 3 is less than 6. 3 is less than 6. And then you ask yourself, is that true? Yes, it is true. So that it means this is always true. And that also always means there's infinitely many solutions. And that is because it is not dependent on x. X cancels out of this equation entirely. What about this one? So to solve this, we would also subtract x on both sides. 1 is greater than 7. Is that true? No, 1 is never greater than 7. So this is never true, and so this is a no solution issue. So x cancels out. It does not depend on x, but this inequality actually doesn't make any sense. So no matter what x value I put in, this will never be true. All right, so I'm going to do just a few problems and then you can try a few yourself. So let me kind of try, let's say the first two. Okay, so let's look at this one. This one, I have this -2 here. I have a -6 and 7. 7 doesn't go into -2. So in this case, it's better if I don't divide both sides by -2. It's better if I just distribute. I hope you guys can see why sometimes I choose to distribute and sometimes I don't. So this case, it's better if I distribute. So this is -6x minus 2 greater than -6x plus 7. So let's try to solve this, and looks like I'm going to add 6x on both sides. So that actually cancels everything out. So -2 greater than 7. -2 greater than 7, is that true? No. So what is the answer? This is never true. Okay, let's try number 2. So same thing here. This left-hand side is pretty complicated. It's better if I just distribute and simplify that. So that is 10x minus 15 minus 7x less than equal to 3x plus 8. So combine like terms on the left. So 10x minus 7x, that is 3x. And then we still have that minus 15 less than equal to 3x plus 8. Subtract 3x on both sides. X's cancel out. -15 less than or equal to 8. That is true. Now, some of you will look at this and say, wait, this doesn't make any sense. Negative 15 is not, it is less than 8, but is not equal to 8. So then you may be stuck with like, this must be sometimes true, because it's only true when negative 15 is less than, but when we talk about equal to, it's not true. Well, let's write this out in sentence form. Negative 15 is less than or equal to 8. The key here is or. You only need to meet one of the requirements. Is it less than? Is it equal to? If it's either one, then the sentence is true. So this one is always true. So I know this is tricky for some students because they're really thinking about it, and I really appreciate that. So this is kind of the explanation of that. All right, let's go ahead and have you guys try these two and practice. So go ahead and give it a try, pause the video, come back and check your answer. And here are the answers, always and sometimes.